Okay, so we're working on 4.6 now. So this says what additional information would prove each pair of triangles congruent by the hypotenuse leg theorem. Remember, there are three things we need. We need a right angle like we have in 8. We need a pair of legs, which we have, and we'd also need hypotenuses. So I'm going to first put the word hypotenuse, and then I'm going to put AC congruent to DF. AC congruent to DF. Okay, number 9, this time we have legs that are equal and hypotenuses equal, so we would need right angles. And so then we put angle M equal angle S equal 90 degrees. Angle M equal angle S equal 90 degrees. So this is the same way you're going to do some that are on the next side. This one we've got right angles equal as well as hypotenuses equal, and so this is going to be legs. And so there would be two possible answers. You can do this leg to this leg, so we could say LJ congruent to OM. Or you can do these legs, so that would be LK congruent to ON. So two possible answers for that one. Okay, number 11. This time we've got our right angles. We've got this reflexive side, which would be the hypotenuse. And so we would need legs. We would need legs like WZ congruent to YX, or we would need WX congruent to YZ. So remember, on that one, your W and Y would correspond because they're both 90 degrees. Any questions on that one? Okay, the next one, we have a couple of blanks over here. It says on coordinate geometry with a graph, basically, complete the paragraph proof that shows that AC and CD are perpendicular. The slope of AC is. So the first thing is, you remember, if it's like this, that means it's negative slope. That's negative slope. And if it's like this, bless you, that'd be positive slope. So what we want for AC is you're going down from 5 to negative 3. That means you're going down 8. So for AC, we're going down 8. And then we're going from negative 3 to positive 1, so that means we're going right 4. So that would mean negative 8 divided by 4, which is negative 2. So the slope of AC is negative 2. Then we're going to do CD. And so this time we're going from here to here, which is positive slope. And you compare your y values, you're going from negative 5 to negative 3, so that means you're going up 2. And we're going from negative 3 to positive 1, which is right 4. So 2/4 would be 1/2. So the slope is 1/2. The product of two slopes is -1 because we're doing -2 times 1/2. So the 2's cancel and you're left with -1. Therefore, the line segments are perpendicular. Therefore, they are perpendicular. So you can think of it as like this: M1 times M2 equal -1, or you could think of it as M1 times -1 over M1 equal -1, because it's the opposite reciprocal. So those are different ways to think about it. Any questions? Okay, so then for 13 it says, how do you know that AB is equal to CD? If they were horizontal or vertical, we could just count, but we're going to need to use the distance formula. And so let's work on that. D equal the square root x2 minus x1 squared plus y2 minus y1 squared. So let's do AB first. So that's going to be the square root x2 minus x1. I'm going to call that -3 minus 1 squared, and 5 minus 3 squared. So remember, if you're typing this on your calculator, you'd get square root parentheses -3 minus 1 squared plus 5 minus 3 squared. Because this is a teacher calculator, it has a T on it, it already simplifies the square root. So that's kind of like a benefit of a teacher calculator. Y'all's would look something like this: the square root parentheses -3 minus 1 squared plus 5 minus 3 squared, enter, and you get this decimal. So in other words, on your calculators, it's not going to give you the right thing, and so you're going to have to simplify your square roots. What I would recommend is just doing all of this part, but take off the square root sign. And so you get 20. So that's what I would recommend. If you'd rather work it individually, you could say -4 squared, which is positive 16, because it's -4 times -4. And this one would be 2 squared, which is 4. So you get square root of 20. Now, you're going to have to break that down into square root of 4 times square root of 5. What you're looking for is a perfect square, like 4, 9, 16, 25, 36, etc. And so that's how you're going to simplify it. And this turns into 2 square root of 5. So 2 square root of 5. You're going to need your distance formula also. And then we'll do the same thing for CD. Now, by the way, if you do the tree instead, that's fine, with 4 times 5, and then here's your pair of 2's. So then you stick your 2 on the outside, and the 5 is a leftover. So whichever way you'd rather do it, Now, if you did 20 as 2 times 10, then you're going to have to say 2 times 5 like that, and then here's your pair of 2's to get 2 square root of 5. But remember to simplify your square roots. Okay? The next thing is we need it for CD. So for CD, we're going to go -3 minus 1 squared, and -5 minus a -3, which is +3 squared. So again, this would be -4 times -4, which is +16, not negative, and then -2 times -2, which is +4. So again, if you get the square root of 16 plus 4, that's square root of 20, which is 2 square root of 5. And so they match. And so that's how we know they're equal, from the distance formula, and you get 2 square root of 5 from both of them. Any questions? Okay, then this is a paragraph proof for these triangles congruent, which are those. ABCD is a right angle from exercise 12. You can also use the product of slopes to show it's a right angle, which is what we did. ACD and ABD share the same hypotenuse. You can use the distance formula to show those are equal. Therefore, by the HL theorem, then the triangles are congruent. In other words, if we go back to our triangles, we would have a set of right angles, we would have hypotenuses that were equal, and we have legs that are equal. Any questions? Okay, so that's the end of Form K. Let's also do a little bit on Form G together, but not all of it. Remember, you do this part, whatever we don't do together. But this is a paragraph proof, so I was going to help you all with it. You're given these are perpendicular, so that means angle RTS and angle RTU are right angles, because perpendicular lines form right angles. So basically the little box right there. Angle RTS and angle RTU are right angles because perpendicular lines form right angles. So then the next part says the reflexive property, and it's RT. So if you don't look at it, you would think, is this going to be RT or TR? Now over here, based on the T's both being right angles, it's going to be RT. So it's RT congruent to RT by the reflexive property of congruence. Then it says it's given that something equal RS, and so it's RU. RU is congruent to RS. So then we would have our reflexive side, which would be legs. We would have our right angles, and we would have our hypotenuses equal. So then we could use HL, or if you want to put HL theorem. That's it for that one. Any questions? Okay, then it says look at exercise 1. If angle RST is 46, then what is RUT? So the S does correspond to the U, and so it's going to be 46 degrees. And then this one has a flow proof, which we're going to do together. It says, write a flow proof and prove these triangles are congruent. So the first thing I'm going to do is the given part, which would be AB congruent to CD. We put a circle around it and put given. The other thing we know is BD is congruent to DB, which is reflexive. So that's going to be two of our pieces that we know. The third piece is about these being right angles. So in the middle here, I'm going to put triangle ABD and triangle CDB are right triangles. Since, well, I'm going to put that as my reason, as my statement. And so that's going to be because angle A and angle C are right angles, and definition of right triangle. So I'm kind of combining these. Instead of doing two steps, I'm just going to say that's one step. So this is one input, here's another input, and here's the other input. If you meet those three inputs, which I'm calling conditions also, if you meet those three conditions, then we can say our triangles are congruent. ABD congruent to triangle CDB from HL. So again, you circle your statement and then you have your reason underneath. So that's what you need for number 3. Any questions? Okay, then for number 4 it says look at exercise 3. How can you prove those triangles are congruent without using HL? So what they're going to do is they're going to call these legs X and this to be Y, and to use the Pythagorean theorem first. So we'd have y squared equal x squared plus, in this case I'm just going to call it BC squared for this triangle. And so that means BC would be the square root of y squared minus x squared. So basically I'm solving for BC, keeping it in terms of x and y. The y squared is on the opposite side, so I've got to move the x squared over, and that's why it's a minus x squared. And so that's what BC is, which also means that's what DA is. And so then we would use side, 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 with the x's equal the y in both triangles, and both of these as the square root of y squared minus x squared. So even though we don't actually know numbers for it, we know these would be equal. Any questions about that? Okay, then this is on constructing a triangle using different methods. then what we're going to do, we're not going to use the protractor or the compass. So you can cross those two out. And there's not enough room for this one on the paragraph proof, so I'm skipping this one also. But you need to do this one and these four and these. You need to do 16 also. Just for a real quick hint on 16, are the triangles congruent? You've got legs that are 7, but this one has a hypotenuse 25. This one you have a leg 25 instead of a hypotenuse. So if you do the Pythagorean theorem for this one, you would have 7 squared plus x squared equal 25 squared. And then just work it on your calculator. 25 squared minus 7 squared is 576. And so then you get this as 24. So I'm going to put 24 for this one. And then on this one, I'm going to call this C. You'd have 7 squared plus 25 squared equals C squared. 7 squared plus 25 squared is 674. So the square root of 674 can't be broken down. It's just that. So these are not congruent. So I'm just going to put no, and then there's all my work. Okay, that's going to be my end of the video. Y'all do the rest, and remember to do all of your Math Excel also.